Okay, so can anybody tell me what I know we've been reviewing trig. What is the formula for average rate of change? Slope, exactly the same as the slope formula, right? Which is y2 minus y1 over x2 minus x1. If it's in a chart, it's like the easiest because it already gives you the actual values. You see what I'm saying? Like on a graph, you have to figure out what the points are, and in the equation, you have to plug the x values in. With the chart, it gives it to you. So first example, determine the average rate of change from x equals 4 to x equals 10. Well, already you can see how easy this is. If you look at the chart, you can figure out what the y values are. You can already see what x or y1 is, right, which is 2. And I can already see what y2 is, which is 0. All right? So, you know, if it's so easy, you really don't have to take notes for this one. You can just follow along. X1 is 4, x2 is 10 because those are the two numbers they gave us. And then if you look at the chart, like I said, you know, your y2 is just this value associated with x equals 10, which is 0. Something went wrong here. Yeah, I see I made a mistake here. So f of x1 is going to be 2, right? Not 10. I gotta fix that. Okay, so f of x1 is 2. F of x2 is 0 based on the chart. Write out the formula like you guys said. Same thing, y2 minus y1 over x2 minus x1. Plug them in. And then simplify this. So we're going to get negative 2 on the top and negative 6 on the bottom, which simplifies to 1/3. 4 minus 10.
But wouldn't it be 10 minus
4? X2 minus x1. Are you right? Are you? You might be correct there. You are correct. It should be 10 minus 4, because this is your y2, right? And this is your y1. Correct. So, thank you for pointing that out. That's going to be negative 2 over positive 6, which gives you negative 1/3. So if you were looking at this graph, I'm not going to go into the actual graph, but or the points or whatever. But basically, you're just going to have a bunch of points, and in between those 2 points is going to have a negative slope like this. Pretty simple. It's going to be down 1 and over 3. That would be the average rate of change. Now, what the actual graph looks like, we don't know, right? Because it's just a bunch of points. But that would give you, again, the slope of the secant line is the same term as average rate of change. So that is the secant line, and that is the slope. I think I just have one more example. This time, it just gives us 2 points, not an actual chart, which is fine. Because from that information, that's all you need. What would be your x1 and y1? Okay, x1 is the first number you plug in, right? Y1 is the first number you get back. X2 is the second number you plug in, and Y2 is the second number you get back. Okay? I think I might have labeled them differently. Yeah, never mind. It doesn't matter what the order is. I think in the actual problem I did it opposite. You'll get the same answer, but just for the sake of consistency, we'll make this one X1, this one Y1, X2, Y2. Okay. So X1, X2. Here's f of x1 based on the point. Going to be 2e. F of x2 is e. Probably going to be either an exponential or a logarithmic function since you got e in the answer. I mean in the y values. All right, so when you plug it in, it's going to be x2, y2 minus y1, sorry, over x2 minus x1. Does anybody know what the top's going to become? What's e minus 2e? negative e, and 1 minus negative 12, 13. If you want to get if you want to kind of think about what the secant line would look like, you could convert it to a decimal. That's going to be about negative 2 over 10, right? Which reduces to negative 1/5. So the secant line would be kind of like this. Go down 1 and over 5. Just for the sake of understanding. But that's all you do with the chart to find the slope of the secant line. It's real easy.